All right, here's 10-2, day 2. We're still with means, but we are just diving into confidence intervals. Okay. Now we've seen 2 sample intervals, but we saw them with proportions. So now it's time to. So the overall feel should be the same. I'm just going to work through 4 steps. So yeah, all the components should feel similar, but again, we'll highlight those particular parts where means are a little bit different. Got the context here. I'm going to go target minus Bosch's, and we were testing basically the average amount of weight it took to rip their plastic bags. To see if, do we have any evidence that one of those stores or the others uses a stronger bag. So here we are. Our interval is going to be for mu sub t minus mu sub b. Looks like I'm going 99% confidence. Mu sub t is the mean capacity of the plastic bags in grams from target. And mu sub b is the mean capacity of plastic bags from Bosch's. We're doing a 2-sample t interval. We have 2 random samples of 5 bags. From Target and Bosch's. Just to clear up any confusion, Bosch's is just another retailer like Target. We don't typically see them here. They're way more common in California and down in the Southwest in Nevada and Arizona. Target shows up all over the place because it's pretty common and they're nationwide, but other retailers are more regional. So you wouldn't find a Bosch's here, but that's, that's what's going on there. For normal, sample size is 5, so we must look at box plots. I'll show you how to do that in class. There's 2 of them. There is a way in the calculator that you can do both at the same time, right? By the way, on the calculator piece, this is going to be a data mode, right? Because you saw on the slide before that it gives you the 5 amounts in grams of how much it took to rip the bag. They did it to 5 different bags, okay? Here's Target, here's Bosch's. Target's, what you would notice is it has a little bit longer rectangle on it. And then its left tail was a little bit shorter than the right. Bosch has had a similar shaped rectangle. The center was a little bit to the right, and then the left tail was a little bit longer. Okay? And then I'll just say over here, no major skews. Or outliers. Okay? Alright, so from this point, I construct my interval. So my statistic would be 12,825.8 minus 9,234. So those are the two means. Okay? You wouldn't get those numbers until you did the interval on the calculator. Okay? Because this is data mode, so I'll show you in the next one where you just get the two means, but here you don't. So yeah, so down here, when you do the calculator, degrees of freedom gets a little bit tricky. Well, I shouldn't say that. It's actually not that tricky for us. It'd be a little bit tricky to get the critical value because there's a fairly complicated formula in your book that shows how you can take the two samples to get your degrees of freedom, right? Which is always sample size minus 1. So if this had been a one sample, it's really, really straightforward. You would just use 4. It's a little bit different with 2 that you can technically use more. There's a way to combine the two samples and you'd get about 7.5. If you use the calculator, that's what it's going to use, and you should use it, okay? The only deal there is you wouldn't be able to go to table B and get your critical value, which is okay. Just leave it as T star, and you're saying that I can't go get it, okay? If you were to use 4 degrees of freedom, you could get the critical value from the table. That's fine, you could do it, but then you have to simplify the formula to get the interval yourself. You couldn't use the one from the calculator because it's going to use 7.5. I would say use the 7.5, copy down the interval from the calculator, and then just leave the critical value as T star. Standard error is going to look like this. Our sample sizes were 5. These are your values for S. This would also be a calculator thing because you'd be using data mode. Until you go to do a 2-sample T interval, you would not have these numbers. So really, after your state step, you would want to go enter your data in list 1 and list 2. I would put target in 1, Bosch's in 2. And then do the interval, because that's going to give you all these numbers that you need. And there's your interval. And we are 99% confident that interval captures the true mean difference in the capacity of plastic grocery bags from Target and Bosch's. Does it give convincing evidence that Target is stronger? No, it doesn't. It looks like from the samples that Target is. This interval is super wide is the issue, and there's two things going on. We're at 99% confidence, and we only had 2 sample sizes of 5. Okay, so the amount of variability from chance is really big. So if you did this with, that's kind of what Part B is alluding to, is if you did this with bigger sample sizes, it looks like you would find that the Target bags can hold more before they rip. Okay, because we almost saw it from here, but the sample sizes are so small, the interval is so wide that 0 worked its way in there. And the bottom end of the interval is saying it's conceivable that the Bosch's bags on average could hold 100 grams more. And on the other side, it's saying that it's possible that the target bags could hold 70 to 100 grams more, but 0 is in there nonetheless. All right, this one will be much nicer. That one was kind of a mean one. You had to do your 2 box plots because your sample sizes were less than 30. You had to use data mode. This one's a totally different story. And I'm kind of trying to illustrate the difference of what you could see a little bit. You've got these 2 months. We've got these random samples of bushels of wheat that were sold, and we're seeing if we're convinced from these samples that the actual average price of a bushel of wheat is different for these 2 months. So we are going to get an interval here for, remember I already said I'm going to do September minus July. Mu sub s, which remember you could call these 1 and 2. I've seen that in class already, that some of you like just go 1 and 2 and then define them as 1 and 2 and kind of figure out what you know, the order that you want to do. It's the true mean price of wheat in September, and mu sub j is the true mean price of wheat in July. We have an SRS of 90 bushels from July. And an SRS of N equals 45 bushels from September. Normal condition is beautiful, 45 and 90, they're both over 30. We're good to use the normal approximation. And this is a stat mode as well, so there is X bar for September. There's X bar for July. Now from the calculator, at this point I should still run the interval on there, because this is going to use 100.45 degrees of freedom. You can look in the book if you want to see the formula for combining the 2 samples to get the degrees of freedom. It's not pretty, and you don't need to know it. What you do need to know is the calculator will use it, and it will tell you. And then I would say, just go T star, and here's your values for S, 0.19 squared over 45. Plus 0.22 squared over 90. .56388 and 0.75612. Okay. Again, this one's a lot nicer. You know, the first one was kind of a wicked one where all kinds of stuff going on, but here with those nice sample sizes and no box plots, it's pretty good. So we are 99% confident that this interval from 0.56388 up to 0.75612 captures the true mean difference between July and September. You could stop there, right? I probably should add to that the true mean difference in price of wheat, you know, just to make sure the context is solid. But But what this really means, and I always like this extra sentence just to kind of drive home what's going on. The price in July appears to have been somewhere between 56 cents more to possibly as much as 75 cents more per bushel than it was in September.